Okay, so yesterday we learned about how we can deal with function recursions and all. Now, one more option in function we have to know is about function closures. Function closure is a general thing actually. Yeah, function closure means it is a technique of configuring a function inside another function. Already we done that, but here the point is the members are the members of outer function are accessible to inner function. The members of outer function are accessible to inner function. So the members of inner function directly accessible to outer function. So closure technique allows the outer function to access the members of inner function. Closure technique allows the outer function to access the members of inner function. That's a closure technique. A closure technique. So defining a function inside function, we done so many times. Fetch method, accessing the values using fetch. We done that so many times, but here the logic is, the point is how you can define the functions and access them with the values defined inside the function. That's what actually the closure technique is. In so many examples, we already done a function inside another function. So here we have to see how this closure works. One small concept we will see here. So let's see, the example is actually, we have a function. So this is outer. And inside the function, we have another function. This is inner. We have outer function and we have inner function. Now, outer function is having a reference where some message is equal to outer function. So we defined message from outer function. Message from outer function. Now here we are having a variable. So outer message is equal to MSG. It's accessible. That means MSG is a member of outer function. It is accessible inside inner function. We can access it. Now we want here this outer message, and here we have inner message. Inner message is equal to, so I will put a message from inner function, and I want to access it outside where inner, so where inner is equal to inner message is not accessible here because it is defined inside this reference. If it is defined in that reference, it is accessible only there. At higher level, if you declare, it is accessible to all inner functions. That's no problem. It is accessible to all inner. But inner is not accessible outside. Then what you have to do is, we have to use a technique. So the technique is, we should return. We have to return outer message plus, in the next line, inner message. That means what is the result? What is the return? What is the return of this inner? Inner is going to store this outer message and inner message. Now what we do is, in outer function, we will declare a variable. So, and we will define as, so message, so final message. This final message will contain inner. Inner is a function which is returning a string. That means when I call this outer, what it can do is, so in this final message, it can store the result of this inner. Inner means it contains both message from outer and message from inner. It is returned. So we can do one more thing here. Instead of final message, we can call directly return, right? We can directly define here, directly return. It should return. So inner is the function. That means what happens? This outer is used as a variable now. Yesterday already we learned that it is used as a variable. In that variable, this result will be stored. The result is nothing but outer message plus inner message. That means we have to just put here document.write. What to write? Outer. Because that is used as a variable now, it can print the message from inner and the message from outer. Both will come. So directly the members of inner function are not accessible to outer. Then we use this technique, and this is called closure. That means we design the inner function in such a way that it returns a value and stores in the reference, so that we can access that returned value and use it in the outer function. So the members of inner function are not directly accessible to outer function. For that, we have to follow this technique. So it's not a new concept. Already we used in various examples. You saw fetch method, where we used fetch method on body load. On body load is already a function. In that function, fetch is already a function. We use it like get categories, get products. All those are functions inside function. So function closure we are using already, where we designed. Shopping example. In shopping example, you see here, what is this get cart items count? It is a function inside another function. This function is used in another function again. Fetch is also a function. It is used in this function. It is returning this data in the form of JSON. It is returning the data. That means these are all closures only. What people don't know is, they think that closure is a special concept. But the concept of closure is defining a function inside function. But extra what you learned here is how the technique is used to send the data of inner function to outer. Directly outer function values are accessible to inner, but inner function values are not accessible to outer. For that, we have to follow this technique. This is the mechanism. This mechanism is called as closure, right? This is syntactically, we have a function outer and we have a function inner. This inner function will return some value, and that will be returned by return inner. The outer function will use that inner. That means finally we access outer, which will return both inner and outer. That is the closure technique. how the closure techniques are used and configured. So function closures, function closure. Example, so this is one example of closure. This is example for closure. This I will post into class, right? So in the functions, this is one concept. Recursions, closures are important. Another point is an anonymous function. So in the functions, you have another important anonymous function. Anonymous function. Anonymous function means, so it is a function without name. It's a function without name. So function without name is an anonymous function. Generally, why we need anonymous functions? Actually, anonymous functions are used in callbacks. Anonymous functions are used in callbacks. We use anonymous functions in callbacks. What is a callback? Already I explained. If you remembered, callback is a technique where the functions will automatically called according to the situation. In array, we return functions. If you remembered, in array, we return functions. That means in array, I told you that we can have a string. So we can have a string like some TV. We can have a Boolean true or false. We can have a function. But when we write function here, if you remember, there is no name for function, right? And how you access that? So suppose this is your array, right? How you access that function? By using array of index number is 2. And it is a function we access like this. I hope you remembered already in array concept I told you. So not only array concept, in our previous function concept also I showed you a function can be inside function. So that means this is called anonymous function. Anonymous function means function without name. Usually we use these functions in callback mechanism, callback technique. Here we used another, if you remembered, we have function, some validate, or say login. If you remembered, we used username or say password, and we have success and failure. And this contains to whenever you access login, password is 1 2 3 4, and success is a function and failure is a function. We write function here also, no name. I hope you remembered this point also. We learned in function. Now these are what? Anonymous functions. Anonymous function means a function without name. Usually we use these in callbacks. Not only that, generally you see we define anonymous function in general development also. So here there are so many ways actually. Suppose we defined var, or say first I said function hello. Hello is a function. In that we put some message. But if function is not having a name, then it is called anonymous. In that I said document.write. So I said hello JavaScript, something like this. And then how do you call it? This is invalid. This is invalid because it is not having a name. Then how do you call it? Generally, this anonymous function can be enclosed in a parenthesis. Anonymous function is enclosed in a parenthesis and you access it by using empty parenthesis. Just you declared a function, it is not working now. It's not working. We have to call the function. Anonymous functions are called with empty parenthesis. We use an empty parenthesis, then it calls that function. Can I call again by using again another empty parenthesis? Anonymous function, it will not work. Anonymous function will execute only once. So, and that should be immediate. You cannot call anonymous function from somewhere else. Immediately you can access it. So there is another technique. This is one method. That means this is another example how we write anonymous function. In callback already we used them. In arrays, in functions, we already used them. This is one technique. Another technique is generally we can define the function in this way. So var hello is equal to, it is a function. So, and it is defined as a function. Now document dot write. So document dot write, suppose hello world, something like this. Now you can see that that is hello is a memory reference. It's a variable. In that variable, there is a function. Now what we do is we call that variable. In that variable, there is an anonymous function. That is variable name. In the variable, there is an anonymous function. How we call anonymous function in variable? By using empty parenthesis. Empty parenthesis. That's what we done. If there is an array and in that index, there is a function. How you call anonymous function in that array? To call anonymous function, we need an empty parenthesis. So that is the meaning of an empty parenthesis. You are using an empty parenthesis. That means you are calling an anonymous function. Anonymous function. So here we call that hello. That means it is defined with that hello. You see, it works. This is anonymous functions. What is the purpose of anonymous function and general function? So suppose I return so function hi. And what is difference between these two? Difference is simple. This function will be called, it will be loaded into memory and it will be called only when required. Situation wise. This is directly loaded into memory. Even you don't need it, it is loaded into memory. It is memory is allocated and it is loaded into the memory. So it is ready to be called. It is occupying more memory. So that is what I said. We use anonymous function in callback. Callback means what? It will load only when it is necessary. It will load into memory only when it is necessary, only when it is requested. So that means if you want a function to load only when it is needed, then better use anonymous. If you want it to be load and get ready so that we can start using it, then use a general function. That means sometimes we want function to get ready with the time of loading the page so that you can start using it. In that case, you have to go with general functions. You want function to load according to situation, then better go with anonymous. That is where we use callback mechanism. That's why the main definition is anonymous functions are used in callbacks. Callbacks means, so they execute. Callback means, you know, what is callback? It is a technique here in the next bottom I will give. Callback is nothing but callback is a technique of accessing function and loading into memory according to state and situation. According to the state and situation. Depending on the state and situation. So That is one concept here. So there is another technique here, configuring. This is another mechanism. How we define anonymous functions and use them. That is. So anonymous functions are nothing but the functions depending on state and situation. So the functions, why they don't have a name? Because they are loaded and stored in the memory only when they are required. We don't give any reference name directly. They will be loaded only when they are required. So that is anonymous. Another important is arrow functions. Arrow functions. Arrow functions. Actually, arrow functions are used to define a function, in shorthand technique. So shorthand technique means you can minify the function logic, function definition. You can minify the function declaration and definition. You can minify the function declaration and definition. So here three options are there. A parenthesis, this is to configure function with parameters. Implies, so configure return value. And curly brace, this is configure set of statements. Syntactically, suppose you return a function is hello, and this function is accepting a message, and it should return a string, so like hello and message, like this. Now this we can write in a shorthand way, hello equal to simply MSG implies hello. This MSG is a expression, dollar expression, right? So here we say hello and dollar MSG. That's it. This is the original way of writing a function, and this is the shorthand way of writing a function. That means now this is the parameter. This is the parameter. This is shorthand. This is shorthand. For example, there is a function welcome. So there is a function welcome, and we have document dot write welcome, like this. So that above is one example, below here another example. This is another syntax. Now if there is a function welcome, how you write in a shorthand way, where welcome is equal to an empty parenthesis, and here implies here document dot write, so welcome. This is shorthand technique of writing the function. the shorthand technique of writing the function. If there are multiple parameters, that means another syntax I will give here. If there are multiple parameters, suppose there is add function a comma b, and it should return a plus b. Then how do we write this? Where add is equal to a comma b implies a plus b. That's it. That's how we write. That is the shorthand technique of writing a function. That means what this parenthesis indicates, function. And what the function will return, this implies indicates return. What return? Return a plus b. That's it. That's how we define the functions. It is shorthand technique. If there are many statements, that means, for example, so we have a function, so print, and if there are so many statements like document.write, so here statement 1, and document.write, so statement 2, like this. Then this how we write is where print is equal to empty parenthesis implies you put a curly brace. Now here we have to say document.write statement 1. So here we define statement 1, and after that semicolon document.write statement 2. Like this we write. Like this we define. We can write in a new line just for understanding sake. We can keep like this just for understanding sake. So this is how we write a function with multiple statements. So that means a lengthy representation of function can be written in a shorthand way, shortcut technique. This is very useful in modern programming. These days, JavaScript developers don't write the traditional function syntax, always lambda only. Always lambda expressions only. That means this is called lambda. We call this as lambda syntax. Actually, this is lambda syntax. So this better you call in JavaScript arrow functions only. So in advanced concept, people call lambda expressions. So, but you call it as arrow function only. But in other technologies, we call with the name lambdas, lambda expressions. But for us, arrow is enough. So everywhere we can follow this technique now. So it's simple to handle and work with that. For example, see now, means I will show here. Already I given you syntax. Suppose we have where add is equal to a comma b implies a plus b. That's it. So that means you now document.write, we call add is a method. Into that we pass 10 comma 20. So this will return, so 10, 20, 30. This is a lambda style. Suppose I am defining, so where print is equal to empty and implies, so document.write, so print method. So I am accessing that print here. After this, I will put a BR so that I can see this print in the next line. It will print it. This is the shorthand technique of writing. So, for example, let's put it in our, this is example. Let's put it in our shopping site. Let's see shopping. This is the fetch method. You see, we designed a shopping one, right? We designed this shopping example. In that, we are fetching the data from API and handling all this. Now, in this example, everything is working fine. Only the point here is now, let's change this function to lambda. Every function you can change to lambda. Here I will show you, see, get categories, fetch method. So fetch method is fetching this URL. After that, then it is using this expression. It is using this expression. Means it is a callback function. Callback function is having a parameter called response. That parameter is returning response.json. So this callback function we can write in this way. Simply response implies response.json. That's it. That's the shorthand technique now. You don't need to write a function, parenthesis, parameter. This is shorthand technique. This is the parameter. You see, this is the parameter. And this parameter is returning JSON. It's a function only. Now, this also we can do that. I will do one thing. I will remove this part. Okay. I will remove that part. Cut. Okay. And I need to define this callback function. What is the parameter? Data implies this time it has to do multiple lines of functionality, then curly brace. And in that, whatever the functionality, that means the data shift all, it will perform iteration. This is lambda. This is lambda. Now you can see get categories, similarly get products. So here what we have to do, remove this, and what we have to define, response implies response.json. That's it. Now similarly, this callback function is doing a lot of work. Here also you can replace. So now you try replacing everything, right? You try replacing all these callback functions with lambda. I showed you one. The same you have to try for others. And you see, so everything is working fine here. That means everything is working fine, accessing the data and display. Now the point is the callback functions I need to update everywhere now, right? Wherever the changes are made, everywhere I need to update and display. Wherever you use callback function, now write lambda, right? I will show you a simple technique here now. We can apply there. In future, we will use in all examples. Here simply, just we will put var. I say products is equal to array. In that we have name, some TV, and category. So electronics. And we have another name. So that is some shoe, and category. And category is what? Footwear. And similarly, we have name, some name I define as some mobile, and this category as electronics. I want to get all the electronic products and store in electronics array. Electronics is an array. I want to get all electronics and store in that array. Earlier, how to do? So we use products dot what filter. In filter we use a callback function, but now simple, what we will do is function is written in a lambda way. Function have only one parameter, then no need to use parenthesis, just you access item implies, what is it? Item dot category is matching with which one? Electronics. That's it. That means now this is a function. Function have a parameter called item. That means actually it is like this. The actual concept behind this is it is a function. So the function is having an item, and what it is returning? It is returning item dot category is equal to electronics. That means this lengthy, and we have made that happen in this way. That means instead of writing that, we are just defining the parameter, and implies indicates return. That means this is parameter and this is return. Implies is return, what it is going to return. We can write in a simple shorthand way. That means now all electronics are present there. We will do one thing, document dot write what electronics. Electronics is an array. That means, so we will copy that. And it will print those objects. Two objects now. Of course, you have to print using an iterator, but I am just writing that electronics here. You know that. So you have electronics of 0. It's an array now. 0 dot name. That means it will print the first one name and display. Second one name. You have to write an iterator and print this. This is just only values. That means this time filtering is done in a simple way. We don't need to write lengthy function. So we can make it short. We can configure. But if there are two parameters, you cannot put comma. Two parameters, then you have to put in parenthesis. In that you have to keep two parameters. Understand? If it is only one parameter, then no need of parenthesis. If there is no parameter, then if there is no parameter, empty parenthesis. If there is no parameter, if there is parameter, only that parameter we have to define. Right? That is the basic approach of defining. So let's do one thing for where item of what electronics. We will print those names. So document dot write item dot name. Let's print only the details of them. And it is accessing those details and printing them. Only electronics. So I can change here. Suppose I want only footwear electronics. This is easy way of filtering. Very complex operations also. For example, this is okay. Suppose if anybody asks like, I want how many electronics are there. This is another example. Suppose I want to show how many electronics are there. Means count. That means document dot write total count of electronics. Count of electronics. How many are there? I want to print them here. How to print total count of electronics? How many electronic products are there? So see what I am doing now. Here I need to just access like this. Array is what? Products. In that what? Filter. Filter if item or simply product implies product dot category is equal to what? Electronics dot length. That's it. That means it will not return the electronic products. It will not return the electronic products. It will return the length of electronic products. That means how many electronics are there, it will find out, and it will return their count. It will not return the elements. It will return the count. That means it will display total electronics products 2. So lengthy expressions, we can make them short now. We can make them simplified by using this. But remember, writing lambda will not change the logic. Logic will be same. Only it will minify your code. Is minifying code will have any effect on the performance? Yes, no. If code is minified, then you already learned that size will decrease, na? Already we discussed that CSS minification, JavaScript minification. To improve the performance, we have to minify the logic. so that it will save that space. It will save the space, right? So this is basic. This is how we need to handle that and configure. This is just only an example for understanding Lambda. Hereafter, everywhere, whenever we are writing functions and options, we can use Lambda. Many times people ask, like, can we use Lambda for events and all other technique? Yes, you can do that. For example, see here, suppose we have doc type HTML head and title some event. So in the body section, then I have to write a click event. That means on click, I want a functionality to execute. That means here we are defining on click. On click, we are pointing towards a function. Suppose say insert click. I am pointing towards a function insert click. So, but see here, I am writing script. So where insert click, I am writing insert click is equal to implies. So this implies, I will just put an alert. So, or alert, or say document dot, right? Say record inserted, we are writing like this. We are configuring in this way. That means now here the button we defined, this is the button, and let's keep the button text as insert. Yeah. Now when I click on that button, it will work. The events, the configurations, everything we define in this way. This is the shorthand way of writing all of them. And how to pass event arguments, object properties, we know. For example, I want to get the button ID. Button ID is btn insert. So I want to print the button ID. Then tell how to define. Here in this parameter, I can just pass this. This is the event argument, right? This we can collect by using obj, formal reference. Here on click, what we have to do, this, and here we want to access the button related ID. That means I will put here ID is equal to how to access it, obj dot what, ID. That means this time it is accessing, this is the event argument, and through that event argument it is accessing btn insert. At which axis they clicked, x axis or y axis they clicked. How we can do that? Another parameter is there. What is it? Event. Later you will learn. In events I will tell you. Through this event parameter, that means now it is having two parameters. Then you cannot write like this. You put a parenthesis, comma, another is e. Through this e, I will access. That means I will say as clicked x position. I will say x position. X position. So position where they clicked x position, we can get that by using e dot client x. That means it will get the x position. I will click here, it gets that x position. That means I click here at the beginning, it says 9 position. So x-axis position where they are clicking, it will get that pixel. This later you will learn, right? Because we haven't learned event arguments and all. So, but these type of options are handled. As of now, you don't need this. Just you put an empty parenthesis and document dot write one message. What is the message? Record inserted. If there are multiple functions to happen, then you have to put in a curly brace. If only one statement is there, not required. So if you have multiple statements, then you have to put in curly brace. So as of now, only one, this is enough. And I don't need this here. On insert click directly, it can handle that functionality. So we can write this for anything. That means we can define even for events. Because wherever function comes and you want a shorthand technique of function, then you have to use this lambda. This is what arrow functions, we call them as arrow function. So the main concept of this is to minify the logic, minify. So functionality will be same, only the number of lines that you write will be reduced. This is very regularly used in modern programming. In future, you are learning Angular, React, Vue-like technologies. You will see that people using these arrow functions only regularly. That means traditional JavaScript based function writing is not followed in modern programming. We use all advanced, right? These are all the points you need to know about functions. So many things we discussed about function. Function parameterless, function parameterized, function different types of parameters, function REST parameters. What is the purpose of REST parameter? REST parameter allows multiple arguments. One parameter allows REST parameter, multiple arguments. Next, we learned about function closures. So function anonymous, right? Function recursions and arrow. In the function, so many things are there, right? Now, once you know all these functions, now we can go into the JavaScript object-oriented programming. JavaScript object-oriented programming. Right. So for that, we need to learn few basic things. You should know that. So in real time, in real time development, in real time development, various programming systems are used. In real time development, various programming systems are used. So are used like we have POPS, we have OBPS, we have OOPS. Different types of programming systems are there. So POPS is actually process oriented programming system. Process oriented programming system. POPS is process oriented programming system. Process oriented programming system, what is good about this is it supports low level features. It supports low level features. It can directly interact with the hardware services. It can directly interact with hardware services. It uses less memory, and it is faster. It is faster in communication. So process-oriented programming system supports low-level features. They can directly interact with hardware services. So they use less memory, and it's faster in communication. These are all the advantages of process-oriented programming system. So example is C, Pascal, COBOL. All these comes under process-oriented programming system. They come under the category of process-oriented programming systems. But they have problem. The problem is code reusability. reusability issues, code separation issues, no dynamic memory allocations, security issues, code security issues. So there is reusability concerns, separation concerns, no dynamic memory allocations, code security issues will be there. All these are the problems of process-oriented programming system. But they have some advantages, they have some features. So they support interacting with hardware services, they use less memory. These are all advantages. Now don't think that so OOPS is the best programming. It is not great in several occasions. Object oriented programming is one concept. It's not great every time. Why? Because, for example, I will tell you one simple concept here. So I hope you know that on Mars, NASA have sent some rovers. Previously, before the Curiosity rover is currently running. Previously, Perseverance and Curiosity are currently running. Previously, they have 3-4 rovers on Mars. And I hope you people know that US have lost communication with those rovers. That's the reason they launched new rovers. Now, the reason why they lost communication with the rovers, because the memory in the rovers is full. Memory in the rover is full and they cannot take new commands. And that means for 4 years, 5 years, they worked, they took commands, and now memory is full. They can't take commands anymore. Then they stops. That means what you are saying that NASA, like people, are out of memory. That means NASA like people are out of memory. That means they are saying that the memory is not sufficient. They can use millions of terabytes. Na? They can't. Because in order to send a rover into Mars and to control it from Earth, I hope you know that it will take approximately 80 sols to reach a command. So to reach a command, 80 sols means, I hope you know, 1 sol is equal to 48 hours on Earth. Sol is a day on Mars. 1 sol is a day on Mars. It is 1 day on Mars is equal to 48 hours on Earth. Now, from NASA Space Center, they give a command like turn right. After 1 month, it will turn right. It will take such time, right? That means it's because it's millions of light years far. I hope you know that. That means a command have to reach there and control a rover on that Mars planet. That is not easy. For that, you can't have a Java program or .NET program. You need a program which can control the machine directly. Lightweight program. A small chip should control. You can't send a hard disk, right? Do you know entire rover weight will be equal to 2 hard disks? Entire rover weight will be that. They can't send heavy weight. They need a lot of fuel, right? That means lightweight. And very important is the commands directly should interact with hardware. In that level, we use these. I hope you people know in space research, majority of programming, we use this Pascal, Visual Pascal. That is very popularly used in space research centers and everywhere. Python machine programming and Pascal such. They can directly interact with hardware. That is the reason, because they can directly interact with hardware. For example, you have an air condition. You have to control air condition with remote. In the air condition, there will be a C program. You know that embedded systems, right? You will not have a Java program in air condition. You will not have a .NET program in air condition, because you have to control the fan up and down. You have to turn on and off the compressor. You have to control the temperature. All such things directly hardware have to control. That for that Java, .NET like programs are not suitable, because a small chip is kept inside it. We have to control the program in that chip using a remote. That is all lightweight programs, and that is these process-oriented programming. Process-oriented programming have great advantages, but problem, reusability concerns, so separation concerns, dynamic allocations. So if you don't need dynamic allocations, separations and all, then you can, because we don't have any extensions. Once we put a program, the program will work in the same way. We don't have any changes in that. Means after few days, will AC updates with new things? The software in AC updates with new things? No, it will have a constant program. After few days, you can't update your washing machine with new features, right? Your refrigerator, your washing machine, your air condition contain programs which are standard, right? They will not update. Update means another machine should come, another new version of that machine should come. That's it. You can't update it. You can't update the software. These are all process oriented. What is problem with process oriented? Updating issues, extension issues, separation issues. If you don't need them, then you can go with process oriented. So process oriented also great. So within less memory, they can handle lot of work, but they have issues. So in various locations, we use process oriented. So better than process oriented in various occasions, we have another OBPS. OBPS is object based programming system. What is the advantage is it supports code separation. So object based programming supports code separation, and it supports code reusability. Code separation and code reusability. It supports code separation, code reusability. It supports dynamic memory allocations, dynamic memory allocations. It supports dynamic memory allocations. So these are all the advantages. So it supports extensions, but some problems are there. So example for this is object-based programming is, so actually object-based programming is JavaScript. So, and VB, Visual Basic. This comes under object-based programming. What are the issues is nothing but code level security issue. Code level securities will be not there. So it will not have contracts, no contracts. What are contracts? I will tell. No templates. What are templates? Also we will discuss. There are no contracts, no templates, no code level security. So no dynamic polymorphism. There is no dynamic polymorphism. This all you will learn. We will discuss. There is no dynamic polymorphism and all this. What is that means? You are going to understand. You will learn about these contracts, templates, code level securities. All these are not there in JavaScript. So JavaScript is not a OOP language. JavaScript is not a OOP language. JavaScript supports some features of OOPs. Means in OOPs, lot of features are there. Out of that, 1-2 are supported by JavaScript. JavaScript is not a OOP language. It is a general object-based programming language, but it supports some features of OOPs. That is the reason if anybody says JavaScript OOP concepts, okay. But nobody should say that JavaScript OOP language. JavaScript is not OOP language. It has some features of OOPs. Several features are not there. That's the reason it's not a OOP language. To overcome these problems, to overcome the problems of these, so we have object-oriented programming system. Object-oriented programming system. Object-oriented programming system. Object-oriented programming system, it supports contracts, it supports templates, it supports dynamic polymorphism, it supports code level security, code security, everything it will support. All the problems that you have with code separation, code reusability, dynamic allocations, these are all common things. In addition to that, it will support all this. What are contracts, templates? We will see, we will discuss. So example for this, so you have TypeScript. TypeScript is an object-oriented programming language. JavaScript is not object-oriented. TypeScript is object-oriented. We have C++, Java, .NET languages, all this comes under so object-oriented programming. This all comes under object-oriented programming. But we have problems also. What are the problems with object-oriented programming? They are tedious. Tedious is nothing but they use more memory. So they are complex. Complex in configuration. So they are complex in configuration. So they are slow. So there are so many issues with object-oriented programming. They need more memory. They are complex configuration, slow in responding. Tedious means all these things are tedious. That makes it tedious. That means dull. So huge, dull. We call this as what? Tedious. These are all the problems with object-oriented programming. For example, I will give you a small example. Suppose you take, suppose you have mobiles. You take a mobile which is not a smartphone. That means you see, suppose a 1200 rupees phone is there. 1200 rupees phone are there. They are not smartphones, right? They are not smartphones. I hope you know that they have an operating system called Symbian. The operating system in them is called Symbian. Symbian is the operating system. Before smartphones, Symbian is the operating system in phones, very popular. Symbian is the operating system of phones. Even today, the phones which are not smartphones, they use this Symbian. 1200 rupees, an ordinary character-based phone. Now you have another mobile. Suppose it is some 20,000 mobile. And this is using, so this is 20,000 rupees mobile, and this is using Android. So, or it is using iOS, right? iOS means it is 70,000 or 80,000. So this is 20,000 rupees mobile and it is using Android as an operating system, which is an OOP language. Android is object oriented programming completely. Now see, take two phones and turn on two phones. Your 1200 rupees phone will get ready first. And this 20,000 rupees phone, it will take time. And see the interactions. You open a phone book, it will take some time to load. It will open immediate. 1200 rupees phone. It is fast in communication. That means you click, just opens, everything opens immediately. That means this phone is faster. And you see everything is slow in your smartphones. That means you say install, it will take some time to install. Open, it will take some time to open. It will not immediate. That means if you are looking for features, you have to compromise with the speed. If you are looking for features, you have to compromise with speed. Not only speed, so the space occupied by that operating system is huge. That means you need more memory. If your RAM capacity is less and you have a lot of data to store, then it will not respond fast. So object oriented programming is not great. So it is okay up to certain limits for certain type. That means if you are trying to use the features, you want to utilize the features, you have to compromise with speed and memory. Do you know earlier, before Windows operating system, do you know there is an operating system called DOS? You know, computer have to work with DOS operating system. DOS is an operating system. Do you know in computers we have a software called WordStar? WordStar is used for MS Word, like letter drafting and all, before MS Word, right? WordStar. And WordStar is used for word processing. Word processing, we use WordStar. Now you have Excel for spreadsheets. Earlier we have to use Lotus. Lotus 123. Lotus 123 is used for Excel spreadsheets. MS Office and DOS. These two are carried in 1.44 MB floppy. Do you know floppy disk? Floppy disk capacity, do you know? 1 MB only. 1.44 MB maximum. In 1 MB, you carry an operating system, you carry a word processor, and you carry your files in it. In 1 MB. Now in 1 MB, nothing will happen. In 1 MB now, you can't even store a photo properly. Earlier, we have to carry an operating system, a word processor, and our personal files in that. 1 MB only, floppy capacity. Floppy capacity maximum 1 MB. There are no much size floppies. 1.44 MB. That is the size of floppy. And we put a floppy, we start the system, we do our work and carry that floppy. We carry an operating system in it. Now operating system itself 2 GB or 5 GB or 10 GB. Minimum 8 GB required for Windows. That means if you are looking for graphical interface, features, mouse operations, touch screens and all, then you have to have more memory. You have to compromise with speed, right? Why? Because they are not easily directly interactable with hardware. They will take time. So object oriented programming is good, but not great. For every situation, OOP is not great, depending on situation. So is JavaScript object oriented programming? If anybody asks, is JavaScript OOP language? What is the answer? No, it is not OOP language. It supports certain certain features of OOP. It supports certain features of OOP. It's not a OOP language. It supports only certain features of OOPs. So then that is the reason for developers, if it is not a OOP language, in the modern technologies, using JavaScript is becoming difficult for developers. That is the reason developers started using an alternative to JavaScript, which is called TypeScript. And as a developer, you have to learn this TypeScript also. We will have a discussion on that. That means TypeScript is now modern client-side programming. TypeScript is more than client-side programming, but now we are not using JavaScript directly in advanced technologies. We are using TypeScript because TypeScript supports all OOP features, but TypeScript is not understandable to browser. Browser can understand only one language. What is it? JavaScript. Using directly JavaScript have no all features. There are no features, all features not there. Then what developers are doing now? They are writing code in TypeScript. This TypeScript code is converted into JavaScript. This will be used by browser. This will be used by browser. This is the flow we are following. Earlier, we have to directly write JavaScript. Even now, today, you are learning directly JavaScript. Some projects use direct JavaScript, but majority of advanced technologies are not using JavaScript. They are going with the TypeScript because to overcome all the features problems that we have with the JavaScript. So that is the basic point. Now, a small point you should know: evolution of OOP languages. That means evolution of OOP. A small history here means how these OOP languages came actually. So how the OOP languages came? LNK introduced object into computer programming in early 1960s. LNK introduced object into computer programming in early 1960s. LNK is the person who introduced a concept called object into computer programming. After that, Johann Ole and Christian Nygaard. Johann Ole and Christian Nygaard, these two people introduced object-oriented programming. These two people introduced the concept called object-oriented programming. The main intention was, they introduced OOP in early 1967. In 1967, they introduced a concept called OOP, object-oriented programming. Actually, the first OOP language is Simula. Simula 67. That is the first object-oriented programming language developed by these two people, Johann Ole and Christian Nygaard. These two people introduced the concept of object-oriented programming. And the first object-oriented programming language was Simula 67. That was in early 1967. Generally, some people know like object-oriented programming means they always start with C++. But before C++ itself, we have object-oriented programming. These two people introduced that. Simulation systems. Actually, how this concept came, what is meant by simulation system? Simulation system means, I hope you people know, simulation system is nothing but, suppose we have computer devices. Because in the early 1960s, I hope you people know, the first computer name is the first computer, you know that first generation computer is ENIAC. ENIAC is the first generation computer. Second generation computer is EDSAC. EDSAC. Third generation computer is PDP. PDP 7, PDP 11, third generation. In the fourth generation, we have PCs. Before PC, it was PDP, EDSAC, ENIAC. These are the computers. Simulation systems, actually, EDSAC was in early 1967s, in early 1960s. This ENIAC was in early 1940s. And this PDP and these in early 1970s. In the 1970s, and these in the early 1980s. 1980s PC came. So the point here is, these are very huge simulation systems. EDSAC, ENIAC, these are very big computer systems. Actually, if you know that, let's see here, I will show you the image. ENIAC. This is ENIAC. This is the computer. This is the first computer. This is the original picture of that first computer. This is the first computer. This is the first computer. ENIAC is the first computer. This is ENIAC. That is the first computer. That is entire computer. Computer means it occupies 2-3 rooms space. 2-3 rooms it will occupy. 2-3 rooms. This is ENIAC first. So after that we have EDSAC. So EDSAC is the second generation. Now 2-3 rooms became 1 room. This is EDSAC. That is the second generation computer. After that PDP. So PDP. So computer. PDP 8 or PDP 11. PDP came on to 1 corner. That means it became from 1 room to 1 corner. After that PC came. These are all computing systems. Simulation systems, these two people were working on simulation systems. Simulation system means, actually, simulation system means, I will show you here. Simulation system means a computer system contains, you have seen computer has lot of parts. That means in 1 room, 1 activity, another room, another activity. They use lot of processors. A simulation system use lot of processors. That means multiple processors will be there. Multiple processor means, so here we have processor 1, we have like processor 2, and we have like processor 3. So a computer contains more than 1 processor. Generally supercomputers and all these have multiple processors. These are called simulation. How this computer starts? A computer with, currently you have laptops, desktops and all. 1 processor only. People say dual core processor. Dual core processor means 1 processor only, 2 cores will be there. Processor is only 1. Processor is only 1. But computers have multiple processors also. How these work? So what happens is, first processor will start. This first processor will invoke the second processor. Then second processor will invoke the third one. Third one will invoke the fourth. Finally, the entire machine will start. This is called simulation system. Simulation system means, so 1 processor, another processor, 1 by 1, all the processors will start. Processor will start. Actually, one important is here. Now, in this kind of environment, they want some code here. And they want the same code to be used in all processors. Then they have to write it again and again. If they want to do some modification, they have to do modification everywhere. This was the problem they were facing. To overcome this problem, these two people, Johann Ole and Christian Nygaard, they invented a concept. Concept is nothing but you put the code logically at one place. You put the code logically at one place and create an object. Through that object, you can access the code from anywhere. That means keep all the code at one place and access it from anywhere using an object. That means I want here then I will create an object, and through that object, we can access that code without rewriting the code. Without rewriting the code, we can reuse the code. This concept was introduced by these two people. These two people invented the concept of object-oriented programming. That means the main concept was code reusability. The main concept is code reusability. They introduced a concept called code reusability, and it was first used in which language? Simula 67. It was used in Simula 67. After that, what happened is another person, Trigue introduced code separation. Code separation. These two people introduced code reusability. Trigue introduced code separation in early 1970s. In early 1970s, by using a framework, called, he introduced a framework called MVC. In the early 1970s, he introduced a framework called MVC. By using that MVC, you can have code reusability and code separation. This MVC is so popular even today. It was introduced in 1970s by Trigue. Now Java people learn this MVC by name Spring. PHP people learn this MVC by name Cake PHP or Code Igniter. Python people will learn this PHP by name Django, Flask and all. Flask, Grok. Ruby people learn this MVC by name Ruby on Rails. We have .NET people learning MVC as ASP.NET MVC. JavaScript people learn MVC. JavaScript have MVC by name Spine. We have MVC in Angular. So we have MVC like in React like applications. So Vue like applications. That means MVC is being used everywhere. And it is not a new concept. It's a very old concept. And every technology knows about this, and every technology is using it. The main purpose is code reusability and code separation. The main intention of that is that after that in 1970s, so C++ came. After that in 1990s, Java came. They made popular. And after that in 2000, so .NET languages came. These made OOP concepts more popular. But before that, so much happened. So C++ is not first object-oriented programming, right? So the first object-oriented programming is Simula. And after that, MVC was introduced with a language called Smalltalk. The language was Smalltalk. So Simula, Smalltalk, C++, JavaScript, Java. In 1990s, it was Java. Then in 2000, .NET languages. These made OOP concepts popular. That means from C++, Java onwards, people came to know about these OOP languages popularly. But before that itself, we have. Only the point is developers don't know them, right? Developers don't know about those programming. So that is the approach actually. This is all the basic history. That means the main concern of, that means what are the features of OOPs? If anybody asks what are the features of OOPs, that means by using OOP languages, what advantages will come? So the features of OOPs are nothing but, so code reusability, code separation, so code extensibility, code security. These all comes under the features. These are all the features of OOPs. Not inheritance, polymorphism, encapsulation. That is what our genius programmers know, right? If you ask what are the features of OOPS, then people will tell a poem. Inheritance, polymorphism, encapsulation. These are not features. They are characteristics of OOPS. They are not features of OOPS. They are the characteristics of OOPS. Features of OOPS are reusability, separation, extensibility, and security. How reusability comes? By using characteristics of OOPS. Characteristics of OOPS are inheritance, that is characteristics. Encapsulation, that is characteristic. Polymorphism, so that is characteristic. Abstraction, that is characteristic. These are the characteristics of OOPS. Inheritance, polymorphism, encapsulation, all these are the characteristics of OOPS, not features of OOPS. Features means what are the advantages? Features means by using OOPS, what benefits we get? The benefits we get: reusability, separation, maintainability, extensibility, security. Now the question is how reusability comes, how reusability can be achieved, how security can be achieved, how extensibility can be achieved. They can be achieved by using these characteristics. So learning OOPS is learning about the characteristics. And once you know the characteristics, these characteristics will enable these features. So these are the features and these are the characteristics. But in JavaScript, you don't have all. In JavaScript, you don't have abstraction, you don't have dynamic polymorphism, you have polymorphism, you have inheritance, but you have limitations. So that means now JavaScript will not support all these. It will support only few. Now we have to know about those options. That means what are JavaScript object-oriented features. Object-oriented features. What are the object-oriented features of JavaScript? These we will learn now. That we'll see in our next session tomorrow, right? Tomorrow we will start learning practically this. Means what it contains, class, what class is, how it works, what are modules, systems, and all we will discuss about them. Tomorrow we will see. Okay.